The fundamental theorem of algebra states that every non-constant polynomial equation with complex coefficients has at least one complex root. To understand why this is true, we need to look at polynomials and complex numbers. A polynomial is an expression that has one or more terms involving variables raised to non-negative integer exponents. The complex numbers include all numbers of the form a plus b, wherein b are real numbers and I represents the imaginary unit square root minus 1. Now, to prove the fundamental theorem of algebra, we need to use a bit of complex analysis. We can show that if a polynomial equation does not have a complex root, then it would be impossible to factorize it completely into linear factors. Since any polynomial can be factored into linear factors, this implies that every non-constant polynomial equation must have at least one complex root. The details of the proof involve concepts from complex analysis, such as the properties of holomorphic functions and the fundamental theorem of calculus. It's a bit more involved to explain without using mathematical language, but I hope this gives you a general understanding of the fundamental theorem of algebra.